Never judge a book by its cover. This is a popular proverb. This also goes on with this chapter, Kinetic Theory of Matter. The name is suggesting a big deal of things like the Big Bang Theory and the many other theories of the science world. But here in the kinetic theory of matter, there is nothing to worry because there is nothing in it. This is a lesson of class 8, 9, 6, 7. Means from junior onwards you are reading this. And if you open the box of the kinetic theory of matter, you would find just a thing which is very old. This is the box of this chapter and we are gonna to unbox it. Let's see what is inside. Now we have unboxed the box of kinetic theory of matter, but we have found something which is very old and we have been reading it from the very past times, and that is the states of matter and things related to it. And I know this is boring, but I'm going to make it very interesting so that you could learn it very well. Have you ever heard a botanist or someone related to biology dealing with chemistry, not in a school life, but any of the professors in any of the colleges? No, right? But a botanist, Robert Brown, did it. He saw some of the particles under the complex microscope. What is its motion? He found that there is none of the motions. He watched them, he saw them, he observed them for almost 15 hours and thought that any of the patterns must be there how they move, because they are in a continuous motion, because they are having some of the kinetic energy inside them, which I will deal with later. Now the particles move something as if five small children in a room, in a whole blank room, five small children, what they will do? They will play, they will fight, they will run around here and there, but they will not have any of the patterns. The same thing, the particles also, which Robert was trying to find out what is their pattern, but he failed. But he said that there is a continuous motion in the particles of matter and which are not having any of the patterns to move, and he called them Brownian motion, which is related to his name. Now let us deal along some of the matter. Now can you say what is matter? Let me not go with the definitions because you can easily find the notes and the definitions in the description below. So let me directly deal with matter. Now in the definition we will have that matter is anything that has mass and occupies space, means it has mass and volume. And later in the higher class or this class only you will learn that there is a small and tiny particle in every matter which is called an atom or a molecule. Now in solid we have, let us take an example of zinc. Okay, it is a matter and it is solid. It is in solid form. The molecules of it, now the molecules of it are in random motion, but it cannot move, as if there is many children in a room, like as if in a small room, in a 50 centimeter cube room, there is 20 children. Can they be adjusted? Up by up they can adjust, but side by side no, right? That is why they cannot move easily. The same thing happened here also, they cannot move, and so they are sad, but some are happy because they are attracting some other ones. And there is always a little bit space which is negligible, and that space is called as intermolecular space. This all which I am dealing is also in chemistry, but here we are reading in physics because it is related to kinetic theory. I will explain it later on. In the liquid, as in the same case, they have a little bit more space and so they could easily move. here and there in Brownian motion. Now, in gas, we have a large area and very few children. So they could move easily here and there with covering large distance. Okay. Now, from here we can understand that solid is having more molecules, liquid is having less molecules, and gas is having the least molecules but in a fixed area or volume. All those volumes should be fixed. Okay. Now, let me see what is kinetic energy. Kinetic energy is the energy which is gained by any of the body due to its motion, and kinetic energy comes under mechanical energy. Here in this you can see the mechanical energy is divided into two of the categories, potential energy and kinetic energy. In potential energy, if any of the body is in rest, completely in rest, it will have some of the energy, and that energy will be called as potential energy. And if a body is moving, then that energy will be called as kinetic energy. In the higher class, you will learn that the formula for potential energy is mgh. You can calculate the potential energy of any of the body by applying the formula mgh, where m stands for mass, g stands for gravitational force, which is 9.8 meter per second square, and h stands for height above the ground. And the formula for kinetic energy is half mv square, where m stands for mass as usual and v stands for velocity or the speed of the body. Now, if we classify matter into two types, we will get pure substances and impure substances. Now, you may have a question that what are pure substances and what are impure substances. Now, can you see what is milk? Pure milk or impure milk? Well, milk in which is a solid form, which is having none of the liquids in it, is a pure substance. But when it is having liquid, which is in liquid form, it will be always and always impure form, because it is having little and very little amount of water in it in the purest of the milk which you get in the home. And we can also understand it by thinking which is completely fixed, which will not change, and which is not fixed. You can easily understand it when you get some of the examples. Now, here are some of the examples. In pure substances, we have water, oxygen, nitrogen, sulfuric acid, nitric oxide, and nitrogen oxide, and nitric oxide, and nitric oxide. Now, if we go in impure substance, we have sand milk mixture. Any other mixture which you see. Now, in this, you have, these are normal elements. Okay, this is not an element, this is a compound. This is normal elements, and they are always pure because they are single alone, and they will be pure. Now, in the compounds, not this, they will be always in some of the ratios. Like hydrogen, there is 2 parts, and oxygen, there is 1 part in water. In sulfuric acid, we have 2 parts of hydrogen, 1 part of sulfur, and 1 part and 4 parts of oxygen, which tells us that they are always fixed. They will not change. Will H2SO4 change? Yes, if 2 we are keeping here, it will change. There will be 2 volumes, but will they be identical? Will they be easily to identify? No, they will be completely same. Exactly. So we will keep it under pure substance. Water, it is pure, not which you drink, because there are very impurities in it, many of the impurities in it, but the water which you completely get, the distilled water for the inverters and all. And sand, the formula is SiO3 or SiO2. Okay, but there will be always some of the impurities in sand, always and always. Sometimes some of the glass pieces or not, there will be always impurities in sand. So we cannot take it under a compound even. Okay, and milk is a type of colloid, means it is also a type of mixture, and mixtures which you eat. Now, further classifying the pure and impure substances, we get here element and compound. And again, further classifying them, we get atom and molecule, which is coming from element, and if we break the compound, we get molecules. Now, in the same here, if we break impure substances, we get type of mixtures. There are many type of mixtures, almost 3, which come under impure substances. But you need to deal with completely this element and compound. Now let us deal with it. Element. Element is the purest form of anything, like gold, silver, which is completely pure. Now gold, many of you have a confusion which is pure gold, which we get in the market. Exactly, if you are thinking that which we are getting in the market it is not pure, you are exactly correct. Because 24 karat of gold is always in liquid form or in semi-solid form, which can be easily broken apart. So we use some we get in the market are made up of German silver and copper, which is mixed into it, a little portion of it, but the price is taken as 24 karat. Okay, so let us forget all this. And compound, which is made up of elements. They are intellect, not intellect. This is linked to it compound. If we break the compounds apart, we can get elements. And the smallest form of an element may be an atom or a molecule. And the smallest form of a compound is molecule. So, what can we take definition of an atom? Atom is the smallest part of an element which may or may not exist independently and take. So now we can see from here that the smallest part of an element is an atom or a molecule. Now from here we are getting a definition that atom is the smallest part of an element which may or may not exist independently. Now let me see you how it may or may not exist independently. Now can we have some of the examples of element which are nitrogen, oxygen and oxygen? Exactly. Can this exist, this and this exist in the air? Means N and O. Can? No, it cannot. It cannot ever exist independently because of some of the chemical reactions, because of some of the molecular structure and atomic structure and all of these. But if we mix one of more at oxygen atom with one of the oxygen atom, we can find O2, which can easily exist independently, and we are breathing it right now. Exactly. And the same goes with nitrogen also. Nitrogen also be N2 form to live independently. But this is having an atom, but this is having a molecule. Because two or more atoms combine to form a molecule. Now so, from here, the minimum number of atoms that can be there in a molecule is 2. 2 atoms or 2 atoms plus 2 is equal to 1 molecule, which may or may not be equal to 1 molecule. is also not equal to one molecule, or also it may be equal to. So what to do? Can we understand it? Yes, exactly, we can understand it. But before that, let us understand what is a molecule. Now, we can find that the molecule is there in both of them, element and compound. Can it be so? Exactly, it can be so. Can you give an example of a compound? The simplest example is H2O. How many atoms of hydrogen are there here? There are two atoms. Now, if you are having difficulty with the number of atoms and molecules, so let me what. Now, there are two of them. If you are having the difficulty with the counting of number of atoms and molecules, so let me show you. Now, in this example, see 6x1, y2 is there. Okay, x and y are none of the elements. They are none of the names or symbols of any of them. I have just taken an example to show you. Now, the number which is denoted here is always and the number of atoms which is there with this. Okay, this one is showing that there is the number of atoms is of x is 1. Is it required to write 1? No, exactly no. It is none of the, if it is 1 then it is no need. If we have 4 here, yes, it is required, exactly it is required, so that we could count the number of atoms, and of y the number of atoms is 2. Now what is 6 here, you may ask me. The 6 is here to show the number of molecules. Now, if ask you what is the number of atoms of X, write in this formula. You will say me 4, but it is exactly wrong. You need to say me 6 into 4, because there are 6 molecules of both. Okay, the both are combining to form 6 molecules. So you need to multiply both of them, which is 32. So the number of atoms of X is 32. Exactly. And the number of Y is 12. Okay. So from here we can understand the number of atoms and molecules. Moving on to here, H2O, we have 2 atoms of hydrogen and 1 atom of oxygen. So totally how many atoms are there? 3 atoms. Exactly 3 atoms are there. The simplest one is NO. Both of them are 1 and 1. So the least number of atoms, 2 atoms. Exactly. Now, if I ask you to give an example of such a compound which is having none of the molecules, can you give me? If you are thinking you can, please give in the comment, because it is none possible. It is not at all possible, because it is always forming with an element, and always an element will have an atom or a compound. Let it be a case of an atom. Okay, it is combining with an atom. A compound is only formed when it is mixing with 2 or more elements. Now, if one element is having 1 atom and the second element is having 1 atom, there will be always 2 atoms at least in the compound. So the least number of atoms that can be in the compound is always 2 atoms. Now, coming on to the main thing of this chapter, the heart and the soul of this chapter, which is kinetic theory. Coming on to the first statement, matter always contains of molecules. I have shown you earlier that well, let me make it clear to you, or let me ask you a question. Is solid a matter? Is liquid a matter? And is gas a matter? Well, if your answer is yes, then you are correct, and no, you can understand it. Uh, so, it contains of molecules. Matter means solid, liquid, gas, plasma, or Einstein-Bose condensate. always contains of molecules, and molecules always, and the molecules are all day always and always in random motion, which is stated in the third theory. Second theory, rather, matter consists of molecules. So molecules are there, which you can see here. 6 molecules are there, very small, but I am making it very large for you so that you can easily see them. And the second one, molecules are always in constant motion. Here you can see that the molecules are always in constant motion from here to here, and those constant motion, the motion name is Brownian motion, which I have said you in the beginning. They attract one another. Now let me say you why they attract one another. Now in the third one we have they attract one another. One molecule attracts another, and one molecule is having a distance with one molecule. Okay, why it happens, how it happens, I'm going to explain you in a brief way. Now coming to the third one, matters attracts one another, we need to understand in a detail so that we could understand this kinetic theory, from where, how it is coming, and the answers to all of your questions. Now let us say that this molecule is attracted towards this molecule. Now so you can see that there is a distance between them, and that distance is known as intermolecular space. The intermolecular space from this molecule to this molecule, or this molecule to respect of this molecule, is, take this distance as 5 meters, and this will be 5 meters. Okay. There will be also between this distance will be there all along. Okay, whether it be a solid, liquid, or a gas, because in solids there is a distance between two of the molecules. Here you can see it, a distance, a little bit distance is there, but that distance is negligible. Okay, but there is distance, the kinetic theory cannot be wrong. Okay, so intermolecular space is there. Now the molecules attract one another. Okay, to understand this you need to understand something of higher standard, which I'm making you understand. So there is an attraction photo from here to here. Okay, from this side and this side, these two molecules, if we consider them as A and B, this molecule is A and B, then they will attract each other. Why? In class 9 CBSE we will have a gravitational force. We will read gravitational force. There it says that there is always an attraction force between any two particles, and the formula for gravitational force is G m1 m2 by d square. Okay, this one we will learn in standard 9. Okay, now here G stands for gravitational constant, and this gravitational force is not for the gravity, it is for the attraction force between any two of the particles, okay. And here G is gravitational constant. To measure the force of attraction we will get G gravitational constant, which values of 6.67 into 10 to the power minus 11. Okay, this is the value for G. Okay, and M1 and M2, this is the product of the two masses. if this is m1, this has a mass of m1 and this has a mass of m2, sit okay, then there is a product of both of the masses, and d square stands from the distance from their centers, means from here to here, from the centers, remember it, from the centers. So it will not be the intermolecular space which is from here to here, it will be greater than the intermolecular space, slightly greater. Okay, so from this we can get the attraction force from of both of the molecules. So there will be attraction force for here, this and this, and this and this. There will be attraction force, this and this also, this and this also, this. Okay, all of them will be, there will be attraction force. Now, here, if A molecule is attracting B and the D molecule is also attracting B, okay, D molecule is also attracting B this side, A molecule is also attracting it, C molecule is also attracting it, then from which side do you think B molecule will go? Will it go A to C or to D? It will go to the place from which the distance is very low. So this is a table for you to understand all the properties of solid, liquid and gas in a very small space and very easily. This table will be there in the description in the PDF. Coming to the end of the chapter, we have the change of states, and here is a table beside me where you can find how change of states are there. This is an easy form to understand and learn the change of states. Here in this direction, any of the arrows represents the mode of heat, and any of the arrow of this directions indicates the less of heats and even cooling.